Hey guys, so today we are going to do notes on systems of equations where there's a different way we can solve, and that's through substitution. So we've looked at what systems of equations are, which is where two linear equations are graphed on the same coordinate plane, or either you have two linear equations and you want to get them into slope-intercept form so that when you graph them you can see, do these have one solution, no solutions, or infinite solutions? If they just give you the graph, you can look on the graph and see from there. But there's also a way where you can substitute a value into one of the equations and then figure out what your x and your y values are. And so that is called substitution. And it's where you take the two equations that you have and you use one to find one of the letters, and then you substitute that back in to find the other. So you can use them both to find your x and your y values. So this is going to be page 63 in your notebook, and I'm going to flip to that page now and show you what today's notes look like. Okay, so here is the title, and I have glued in the document that I attached to the Google Drive or the Google Classroom for today. I just cut it out and glued it right onto the top, and these are just the steps to help you guys remember. I'm going to show you this example right here, and then I'm also going to give you another example, so that will be very helpful as well. So the only thing that we're going to do today is these substitution notes, and then we'll do some examples together. So if you have any other questions, you can always let me know on the Zoom, or you can email me. So when you have two equations, instead of trying to graph them to find out if there's one solution, no solutions, or many, you can substitute one into the other and figure out what that x value and that y value would be. If there's one x value that equals one y value, that would be one solution. And tomorrow we're going to look at special cases where when you try to do this, it's not going to work, and that would be no solution. Or when you try to do this, the letters completely go away, and that would be infinite solutions. So today is just going to be your standard one solution, two linear equations put together. So first you're going to write your equations, and you're going to solve one of them for x or y. I typically like to solve for y and then plug that in, but you can choose either one. When it says solve one equation, that means get it by itself. So whenever I say solve for x, that means get x by itself. If I were to say solve for y, that means get y by itself. Once you have it set equal to x equals everything or y equals everything, you're going to substitute everything that you have in for that variable in the other equation. Then you'll simplify and solve it, and then take that answer and go back and put it into the other equation. And you'll check your answer by plugging them in and see. But we're going to go through these steps with this first problem that we have here. So it says there are two numbers. Okay, so we're going to assume that that's x and y. Okay? They can't both be the same letter. One letter is going to represent one number, the other letter will represent another number. The first number plus 17 equals the second number. So this first number is going to be x, the second number is going to be y. So if we were to write that as an equation, it's telling us the first number plus 17 equals the second number, right? So those are our two numbers. We don't know them yet, so you just have to put letters wherever it says number, because we don't know what that is. And then it says also, so there's another equation, 5 times the first number, and we set up here the first number is x. So now we have 5 times the first number minus 3 equals the second number. So we have two equations here. X plus 17 equals y, and 5x minus 3 equals y. So what we're going to do is we need to solve one of them for x or for y. Well, look, they're both already solved for a y. Y is already by itself. So y not only equals x plus 17, but y also equals 5x minus 3, meaning they're interchangeable. So if this equals y and this also equals y, doesn't that mean they equal each other? Because this is saying y is this, and this is saying, well, y is also this. So if this and this is y, they are the same. It's kind of like saying 2 plus 3 equals 5 and 1 plus 4 equals 5. So 2 plus 3 and 1 plus 4 also equal each other, right? So what you're going to do, since they're already solved for y, right here, we solved one of them for y, well, they're both solved for y. We're going to substitute for that variable into the other equation. So all of this is going to go in right here for the variable in the other equation. Let me go back up here and look at that. Substitute that in for the variable in the other equation. So if this is what y equals, put it where y is. It does not go where x is. If this is y, put it where y is in the other equation. So now we have 5x minus 3 equals x plus 17, right? They're the same. They're equal to each other. We can now solve for x because our y's are completely gone. We plugged it in place of the y, and now we can solve for x and figure out what x is. And then once we know what x is, we only have one missing variable. We can always solve for one variable. In these equations up here, it's hard to solve for a variable because we're missing 2 of them. That's too many. If you're only missing 1, you can figure that out. And then once you figure that out, you can plug it back in, and then you're only missing y. So we're going to solve this. We're going to say, okay, let's combine our x's. Let's move this x over here. And now we have 4x minus 3 equals 17. And then let's add 3 to both sides. Now we have 4x equals 20. Divide that 4 away. We have x equals 5. Well, let's take that. Let's go back to either one that you want to go to, and plug it in. So since we just used this equation right here, we plugged this one into this, we're going to take this one and put it back over here. So we're going to say, all right, I'm going to take this. I'm going to put it right there. I'm going to say, well, if x is 5, we figured out that 5 plus 17 is what y is going to equal. That's super easy. 17 plus 5, that's 22. So once you use one equation to solve for one of your letters, take it back and plug it into the other one and figure out what your other missing variable is. So we solved for x, and then we used that to figure out what y was, right? And again, if you, either equation here, if you plug 5 in here, 5 times 5 is 25, minus 3 is 22, right? So these should work for both equations. When x is 5, y is 22, for both of them. So they would both have one solution at that point, 5, 22. Now, this was kind of easy because they were both already set up equal to y, but what if I gave you, we'll do one more, and we'll title this one Example 1. What if I gave you (3x minus 12 equals 2y). Oops, I apologize for that. And then y equals x plus 4. And I want to know what x and y are. I want you to solve this system of equations. Well, this one is already set where y equals everything. So remember, the instructions tell us to solve one of them for x or y. You want to get that letter by itself. Well, this one already has y by itself. So what I'm going to do is, since y equals this, I'm going to take this and plug it in where the y is. Remember, plug it in place of the variable in the other equation, a variable that matches. So if this is what y is, I'm going to plug it in where y is. So my next part is going to be 3x minus 12 equals 2 parentheses x plus 4. So I'm basically plugging in what y equals where y is. Remember, if we know what a letter is, we can plug in what we know for that letter. The letter is just there because we don't know what it is. But the minute that you do, you want to plug in everything that you know so that you can get rid of that letter and you can solve for it. So now in this equation, the only letters we have are x's. So I can solve for one missing letter. I can do that. So I'm going to distribute right here. 2 times x is 2x, 2 times 4 is 8, and then bring this down, 3x minus 12. Now my goal again is to get all my x's together. So I have x minus 12 equals 8. Bring this 12 over here, and then we have x equals 20. So now that I know what my x value is, I'm going to take that and I'm going to plug it into this equation, the other one that I did not use. Also, it's much simpler. And say, okay, well, if x is 20, now I can solve for y. I can say y equals 20 plus 4. Because you see, I replaced the x that I now know with what I know it is. It's 20. And so now if I know what the x is, there's only one missing letter, y. And as long as there's just one, we can solve for it. That simplified would be y equals 24. See? So these are two examples of how you can use substitution to solve for systems of equations by solving one of them for one letter and plugging in what that equals for that letter in the other equation. And then you can just backtrack and take your answers and plug them in and solve for your missing variables. And this way, instead of having to graph both of these and see where they meet, this would be very far up on the coordinate plane. You can use substitution, and it's a really cool method. So at this point, you're free and you're done with the video. Thank you guys so much for doing your notes.